Hello, everybody. Turn to page 15 in your green notebooks. It's a short topic. It's a useful technique to have in your bag. If you know one of the trig functions, you can find a lot of the other ones. So I'm going to illustrate the kind of idea, and then you'll practice it in the problem set. Here's the kind of idea. We're going to use a right triangle model to come up with a scenario that describes the meaning of this equation. So let's draw a right triangle. So x is in the position of an angle, like the input to a trig function is always interpreted as an angle, so I can label that x. I know that sine describes opposite over hypotenuse, and here I've got a number over another number. So we can interpret that 2 as the length of the opposite side, and we can interpret the 3 as the length of the hypotenuse. Okay, so what if we want to find literally anything else like cotangent? So let's rewrite cotangent. Cosine over sine. Okay, well, we already know what sine of x is. Sine of x is 2/3. So what's cosine of x? Let's try and figure it out here. You know a lot of math about right triangles. We know that this side squared plus that side squared equals the hypotenuse squared. So I know question mark squared plus 2 squared equals 3 squared. So that means question mark squared equals 9 minus 4, which is 5. So that means question mark equals square root 5. Although I'll have something to say about that in just a second. There's actually one more answer that would make sense. But going back over here, so we know that this side length is root 5, so that must mean that cosine is adjacent over hypotenuse, so that's root 5 over 3. And so now we can finally know what cotangent is, because we've got root 5 over 3 divided by 2 over 3. And so that simplifies as root 5 over 2. I'm going to ask about a lot of other trig functions also, but it's always the same approach. The approach is create a model, a right triangle model, fill in information you know based on what's given, solve for things that you don't know, and then once you know all the side lengths, you can answer questions about any trig function you want. Okay, so let's visit the last thing that was a little bit weird. So if I take the square root of both sides, that should give me plus or minus root 5. Does it really make sense to have minus root 5 as an answer? Here's where the model might mislead us, because it maybe doesn't make sense to have negative root 5 be a length, because lengths are always positive. Instead, we could imagine a model that's on a circle. So here we said, if we're going to go up a height of 2, this is a height of 1, so a height of 2 would be about there. So there's some particular angle where the height is 2 and the hypotenuse is 3. And we don't know what angle that is. That angle was x. But what we know is that that distance was root 5. You can also imagine another angle x out in this direction. And the 2 and the 3 measurements still apply. It's still a height of 2. The hypotenuse would still be a distance of 3, except this time we'd be at an x-coordinate of negative root 5. So both the plus and the minus root 5 make sense because there's 2 different answers for what that angle x could be. So you don't necessarily need to reproduce a picture like this. I'm just trying to convince you that it makes sense to have like when you take the square root here, it makes sense to have the negative distance still be an answer. So our final answer actually would be that this is plus or minus root 5, which means that cosine would be plus or minus root 5 over 3, which means that cotangent would be plus or minus root 5 over 2. So if sine is 2 over 3, there's actually 2 different answers for cotangent that might work. There's plus root 5 over 2, and there's also minus root 5 over 2. Let's just do one more note. All of this is exactly the same if you don't use a number. So like, let's say I wanted this to be 2 to the power of k, for example. The whole analysis still goes through. X is my angle. Here I don't have a number over a number, but you could imagine this as 2 to the k over 1. So that means the opposite side would be 2 to the k, the hypotenuse would be 1, and everything else is just the same. It's just that you would treat 2 to the k like a number, because it is a number. So you would solve through in just the same way. Okay, come back for the next video.